Hello, good afternoon. My name is Andrea Diaz, and today I'm going to be talking about semiconductors. The topics are going to be covered today are what is a semiconductor, how does a semiconductor work, and types and properties of semiconductors. What is a semiconductor? Solid-state materials are commonly grouped into three classes: insulators, semiconductors, and conductors. Semiconductors are a group of materials having conductivities between those of metals and insulators. Semiconductors are commonly bonded materials for which heat energy is sufficient to promote electrons from bonding energy levels to the localized energy levels. The conductivity of semiconductors is a sensitive function of impurity content. The substitution of semiconductors atoms by atoms with one fewer or more valence electrons. Introducing positive whole or negative charge carriers into materials. The resistivity of semiconductors varies in wide limits and is reduced to a very great extent with an increase of temperature. Here you can see in my PowerPoint the three types of solid-state materials. Two general classifications of semiconductors are the element semiconductor materials, found in group 4 of the periodic table. The element materials, those that are composed of single spaces of atoms, are silicon and germanium. Silicon is by far the most common semiconductor used in an integrated circuits. Here in my power, you can see the periodic table and the germanium and silicon that are the two that I just mentioned. The compound semiconductors, most of which are formed from special combinations of group 3 and group 5 elements, are divided in two. The two-element or binary compounds such as gallium arsenide or gallium phosphide are formed by combining group 3 and group 5 element. Gallium arsenide is one of the more common of the compound semiconductors. Its good optional properties make it useful in optical devices. GaAs is also used in specialized applications in which, for example, high speed is required. We can also form a three-element or ternary semiconductors. An example is ALX JAX minus 1, as in which the subscription X indicates the fraction of the lower atomic number element component. Most complex semiconductors can also be formed that provide flexibility when choosing materials properties. Now I'm going to explain to you how does a semiconductor work. The properties that designate an element as a semiconductor have to do mainly with the behavior of the electrons in the element's valence shell and the spatial arrangement in the solid state, called the crystal lattice that it's over here shown in my slide. The electrons in the inner shells of an atom do not normally leave the atom, but the electrons which are in the outermost shell, so-called valence shell, do not always remain confined to the same atom. Most of these valence electrons move into random matter and may travel from one atom to another in a crystal lattice. Here you can see the valence shell as well in my PowerPoint. The foundation of the behavior of semiconductors has two main theoretical axes: band theory and mobility of electron holes. Bound theory, we know that the energy of the element in an atom is quantized. When we try to assemble a lattice of a solid with an n atoms, then each level of an atom must be divided into n levels in the solid. This division of net and compact energy levels forms energy bands that shows here in my power band theory valence. The valence band, the energy band involving the energy levels of valence electron, is known as the valence band. It is the highest occupied energy band. When compared with insulators, the band gap in a semiconductor is smaller. It allows the electrons in the valence band to jump into the conduction band and receiving any extra energy. Now I'm going to talk to you about the conduction band. It is the lowest unoccupied band that includes the energy levels of the positive or negative charge carriers. It has conducting electrons resulting in the flow of current. The conduction band possesses high energy level and is generally empty. The conduction band is the semiconductors accept. The conduction band in semiconductors accepts the electron from the valence band. Holes and electron. Both electron and hole are equal in magnitude but opposites in polarity. Now I'm going to talk to you about types and properties. First, types and property in this intrinsic. An intrinsic type of semiconductors material is made to be very pure chemical. It is made up for only a single type of element, semiconductors, that is shown here in my slide as well. In the case of extrinsic semiconductors, two types of impurities are added to the crystalline lattice of the semiconductor. This process is called doping. Said impurities which are added to the solid can be electron donors or acceptors. A semiconductor that is doped with a donor impurity is called N-type semiconductors. One is doped with an acceptor impurity is called P-type semiconductors. Here are the properties: holes, temperature, conductor electron control, and conductivity. Conductor electricity in a controlled manner. Semiconductors can conduct electricity under preferable conditions or circumstances. This unique property makes it an excellent material for conducting electricity in a controlled manner as needed. Holes, unlike conductors, charge carriers in semiconductors arise only due to external energy. It causes a certain number of valence electrons to cross the energy gap and jump into conduction band, leaving an equal number of unoccupied energy state. This is holes. Conduction due to electrons and holes are equally important. Conductivity 10 to 10 sm Siemens per meter. Temperature. The resistivity of semiconductors decreases with temperature because the number of charge carriers increases rapidly with increases in temperature. The properties of semiconductors make them part of the design of technology artifacts part of our daily life, such as temperature sensors are made with semiconductors devices. They are used in 3D printing machines, using microchips and autosons cards. It is used in calculators, solar panels, computers, and other electrical devices. So semiconductors are really important for our daily life, even though we maybe don't know much about it. This is the reference and websites I use to get a lot of my information. I hope you guys liked it and you guys enjoyed it and learned a little bit from semiconductors. Thank you.